to the cloud.
You got it.
There we go. Welcome tonight. I'm Kit Gage. I'm the advocacy director for Friends of Sligo Creek, and the a couple of our usual folks doing hosting Zoom couldn't come, so I get to do it, which is fun because I really like this topic and this issue. The Friends of Sligo Creek is a nonprofit organization protecting, improving, and appreciating Sligo Creek, the park, and the surrounding watershed. We've been around for we're into our about 20th year, which is pretty remarkable for us. And it's an amazing organization considering we have this, we are supporting this skinny little creek and a skinny little park, but there's a lot of love involved in not just by people who are in Friends of Sligo Creek, but people who uh, live near and around it. We, as with tonight, we do a lot of different kinds of things, and I'd urge you to go visit the friendsofsligocreek.org website, which is newish and much improved. And you can really see the variety of what we do. So there are a number of committees doing a bunch of different things, and I see a number of the chairs of our various committees, folks who are doing water quality and water watchdog. As I said, I'm doing advocacy. We have people who do litter cleanups, and a bunch of us are weed warriors. So there's a whole lot of, if you're not already involved in the organization, I'd urge you to join it. It's free, although we very much welcome donations. And you just go to the website and click join, and you can join the listserv. You'll get the newsletter, and you can figure out how you might want to get involved. So I think, we have when hopefully pretty soon we'll start having walks. We've moved our talks to Zoom, which has for the last couple of years, which has obviously permitted a lot more flexibility. But I'll be happy when we get to do some back to some in-person talks. The next dates to note coming up there's several of them, but the one of maybe most interest is Sweep the Creek, which we do typically twice a year. And this year it's coming up April 23rd and 24th. And those will the creek is divided up into different sections, and different sections will have the 23rd and other sections will have the 24th. And if you go to the website or check in the newsletter, you'll see which section you want to do and which day of that weekend we're doing Sweep the Creek. And it's trash collection. We provide people with bags and gloves and mute that. Bags and gloves, and send you off in different directions, and it's fun. It's just a couple hours in the morning of one or the other of those days. So April 23rd or 24th. And I'm going to turn it over to Tom Walton to introduce our speakers tonight. And we're really grateful to have them and delighted to have this program. And we will have a Q&A at the end, which will be starting around 8:30 or so. And if you would please, if you have questions that you're thinking of, as you're thinking of them, put them in the chat. It makes it a little bit easier to organize handling the questions. We may well just do them live, but if you put them in the chat, that gives us an idea, and the speakers an idea of what kinds of issues you want to know more about. Okay, take it away, Tom.
Thank you very much, Kit, and good evening to everybody. This is fun for me because I've been using USGS maps data publication since I was a graduate student in regional planning in 1970. one of my favorite publications. I'm not sure you can see it well. I keep it. It was written in 1978. The title is Nature to be Commanded, and the rest of the phrase that goes with that is must be obeyed. So that was written by Francis Bacon in 1620. I'm not sure we've learned it yet. Anyway, tonight we are very lucky to have Charles Walker and Erica Warner from USGS, from the Maryland, Delaware, DC Water Science Center, which main office is in Baltimore. Chuck Walker's the Associate Director for Data there, and he manages the USGS hydrologic data collection networks for surface water, groundwater, water quality, and precipitation in Maryland, Delaware, and District of Columbia. He earned his Bachelor of Science in Environmental Resource Management, MS in Environmental Pollution Control, and a PhD in Soil Science, all from Penn State University. And I'm a former resident of Pennsylvania. Erica is a hydrologic technician with USGS, the same office. She graduated from Towson University in 2018 with a bachelor's degree in biology and ecology. She started her career working with environmental quality resources, focusing on stream restoration projects, and then joined USGS in 2020. She is the lead technician for the water quality monitoring in Sligo Creek. Perhaps we've seen her there. I have seen people below the weir several times, and I'll look for you next time. So with that, the podium is yours, and we're very much looking forward to what you have to tell us.
Sure. Well, I appreciate and I thank everybody for welcoming us tonight. You know, we're going to try to go through a little bit of what USGS is, who we are, what we are doing at Sligo, so that everybody knows when they see us out there what exactly we're doing, and kind of ending up on how everybody can see the results from our samples and the data that we collect. I've asked Erica to come and specifically talk about the water quality sampling that she does, and the operation of the continuous water quality sensors there. And I appreciate her taking time this evening to talk about that as well. So let me get some mechanics going here, sharing my screen, and we can get started. All right, everybody should be able to see my screen shortly.
Yep, right. You're up.
See that, and now we're going to do a presentation. Start the presentation, hopefully. There we go.
Okay.
We're all good?
Yep.
All right. So one of the important things to note about the site is the site number 01650-800. That becomes very important if you start to look for the data. So jot that down and we can show you towards the end where you may find data for that. A little bit about the USGS. I'm going to start very high level and kind of work our way down to Sligo Creek, how we get there. USGS is a federal agency. We're part of the Department of Interior. We were created in 1879, and Clarence King, who's pictured here, was the first director. A lot of people think it's John Wesley Powell. He was actually the second director of the USGS. But Clarence King was the first director. We were initially charged with the classification of public lands, essentially looking into the geology of the country, looking at the resources, trying to map resources. Of very important to note as well is we are a science agency, probably one of the premier earth science agencies, and we have absolutely no regulatory authority. And we take pride in that. We provide data for those who make regulations and enforce regulations and need to follow regulations, but we do not make any regulations and we do not enforce them. So, and again, we're part of the Department of Interior. Within the USGS, there's 5 mission areas. Some of this has been talked about tonight. Probably one that is the most recognized would be the natural hazards mission area. That's the earthquake people. So whenever you hear on the news, there was a earthquake, in California with a magnitude of 5.6, according to USGS. That's one of our mission areas. Erica and I are in the water resources mission area. We deal with everything water. There's also energy and minerals, who map out the resources, ecosystems, the fuzzy animal group, and the core science systems, who really the mapping group is one of the main focuses that they have. The 7.5 quadrangle maps that we're all used to, which, by the way, this is just out. You can now find and create your own 7.5 minute quad map in the center of your choosing. So that there used to be a grid where you had to pick out quad map. Now you actually choose the center of that. So as luck usually had it, the map that you needed was right on a border, and you needed like 4 maps. Now you can make one map in the middle and you're good to go. But I digress. So we're in the water mission area, resources, and moving down a little bit further, we're part of the Maryland, Delaware, DC Water Science Center. Every state in the country has Water Science Center representation. In the past number of years, the science centers have merged. One science center for a number of states, but there are still offices in every state. Our center itself has about 90 scientists, working on 100 these days, and about 40 hydrologic technicians. And we have offices in Frostburg, Maryland, and Dover, Delaware. Those are field offices, and the main office is on UMBC campus in the Tech Park in Baltimore, Maryland. Our office is kind of split into 2 different sections. We have a group of folks that collect data, any type of water data that you can think of. We collect that. That's kind of the section that I head up. And then we also have a group of folks that interpret the data, the science, the studies section, we call it. And they take and use our data and other data and make interpretations from that. They publish reports based on what the needs are. Within our data section, we run about 150 stream gauges, 40 continuous water quality sites, 30 continuous groundwater sites. We have a yearly synoptic where we measure 400 wells across Maryland. We do that once a year. We have a smaller one in April, and a number of precipitation gauges. So we run quite a bit. Not only that's the continuous part, but we also collect discrete water quality samples from about a dozen or 15 different sites across the 2 states in DC. So quite a decent size program for our office. One of the other things that I'd like to talk about with folks when I talk about the USGS is funding our science. We are a federal agency, as I mentioned earlier. We have a unique funding model. The majority of our data that we collect is funded by what we term as cooperators. And the cooperators are typically federal, state, and local agencies. We also have agreements and cooperations with universities and different associations to fund the collection. We're typically hired for a couple reasons. Long-term high quality data, that's basically our networks. We have a lot of long-term data. And then the other part is difficult water problems where there's been spills or questions on that are difficult to answer. We usually get called in there too. So again, if we didn't have our cooperators, we would not be able to monitor the sites that we do. If we relied on federal only funding, we would be specifically for stream gauging, we would probably be able to run about 10 sites. And our local cooperators and other federal agencies as well, and state agencies fund the remaining work that we do. So, and we have a number of different types of agreements, but another picture here of long-term data collection. Our center has one of the longest continuous running stream gauges in the country. Point of Rocks on the Potomac was started in 1895, and we have data back for the stream flow since 1895 for that site. So that's when we look to establish new areas and new gauges, we look for a long-term site that we can continue to monitor over time, because it has proven to be very valuable for needs that we would never even think of before, and they come into play. And the long-term data is really important in that fact. You know, one such parameter that is, you know, becoming more and more important these days would be temperature. And before, we'd be monitoring temperature just kind of as a parameter where it affects other parameters that we are monitoring, and we needed to make sure that that was being measured accurately. But nowadays, we're starting to look at temperature and looking at trends in temperatures over time to see how they're changing. So long-term data collection is very important to us, and something that we try to really make sure that we are able to do and store that data for that amount of time. I mentioned the cooperators here again, the Sligo Creek, in which Erica is going to be talking about next. Is one of our cooperators that pay for that is Montgomery County, and we certainly appreciate that. They fund a lot of our work in and around the area, and we do appreciate that. We have probably over 30 different cooperators, and we have agreements with each one of them. The thing about that is it really keeps our science relevant. If there's a local need for that data, or a state need, or even another federal agency need, we can work with them and start collecting that. And then on the other end of it, if there isn't a need for that data, then we will not have funding to collect it, and we'll stop collection. So, you know, it's very relevant in that end of things. And I was mentioning earlier when we started, and when I first logged on here, the cooperators that you see here, they have a specific need for the data. The data, it becomes part of a network where other folks use the same data that folks that these cooperators are paying for. So a lot of the group that we work with realize that, and they try to pick up pieces where others lose it to maintain our network status. So we might be collecting data at Sligo Creek for Montgomery County for their specific reason, but as we've heard already, that folks from this group use that for other reasons, and there's probably 10, 15, 20 other reasons that data from this site are being used, anywhere from graduate school projects to looking at trends over time and space and things of that nature. So it becomes very useful data. And so that's kind of a overview of the USGS, our Water Science Center, and how we operate. Next, I'm going to hand the show over to Erica, and she's going to explain a little bit about what you're actually seeing when you go past Sligo and you see USGS folks there, and what we're actually doing there. So I will operate the slideshow here, Erica, and you just tell next, and I will hit the button.
Okay, so hi everyone. Again, I'm Erica Warner. I'm a frequent flyer at Sligo. So I'm going to be talking today about the water quality data collection that we do. And again, like Chuck mentioned, the project itself is funded by the Montgomery County Department of Environmental Protection. And here's just a fun photo of Sligo itself. Okay. So what do we do? So at Sligo, we collect two different types of water quality data, discrete data and continuous. So we collect samples at Sligo Creek on a monthly basis as well as during storm events. This project began July 2012, and since we have collected 109 monthly samples and 181 storm samples. For sample collection across the US, USGS follows very strict sampling methods and protocols outlined in the USGS National Field Manual. Discrete data is data resulting from individual water quality sample collections. For collections, we collect evenly across the cross-section to ensure we get an accurate representation of the stream. We also use a specific transit rate to ensure that we also are getting accurate representation based on the flow of the water, which is also referred to as isokinetic sampling, which you can see in the photo to the right. Here's a picture of myself getting a monthly sample from Sligo. So we work from left to right evenly across that cross section. And here I'm using a DH81 to get the isokinetic sample, which is basically the flow into the bottle is the same as the flow of the stream coming in. And we do that because if it is not the same, then the sample is considered biased because we're capturing more sediment. So the samples that we analyze are analyzed for nutrients, nitrogen and phosphorus, select trace metals, chloride, E. coli bacteria, total suspended solids, and suspended sediment. We also collect quality control samples, such as which we refer to as blanks, known and replicates, which ensure we're getting unbiased, non-contaminated sampling that is being collected. Okay. And then this is where you guys might see me often, is the gauge box for our auto sampler. This is actually where I get the most questions when I'm at Sligo. So the auto sampler is there to help us collect storm samples so we do not miss a good storm event. Since this urban site is very flashy, which I'm sure most of you guys know, it can go from base flow to super high really quickly, which makes it unsafe for us to sample. So that this way we can sample it when it is not safe for us to go into the stream itself. Our goal here is 1 storm sample per month. Storm samples help us capture hydrologic and seasonal variability of the stream characteristics. This auto sampler has an intake line in a fixed area in the stream, which basically is there to make sure we get a sample from the same spot each time. We can remotely set the auto sampler, which is very cool. So we can be at home or in the office and set it so that it will collect and we don't miss a good storm. Or like I said, if it's unsafe, we can set it remotely. So this auto sampler collects 2 samples from 1 trigger event. There will be a rise, peak, or a fall, and we hope to collect 2 out of the 3 of those for each hydrograph. And then this is to the left is just showing the bottles that are inside the machine inside the box. Okay. So when I refer to a storm hydrograph, this is what I'm talking about. So this is a graph from a storm that we had on 9/1/2021. Got almost 1.5 inches of rain for this event. So you can see how quickly here at Sligo, it goes from under 1 foot for the gauge height all the way up to 6 feet really quickly, which is, again, it's a very flashy site. You can see that we had a really good rise, peak, and fall event. And then you can see we had another small event after, but this is what we refer to as the storm hydrograph. And this is what we use when we are looking for the auto sampler collections. Okay. And then this I just added in there just for you guys to get a visual. To the left is a base flow, and this is where this is what it looks like when we usually do a monthly visit, nice and calm. And then to the right is a high flow event for a storm. In this instance, it was still safe enough for us to sample. So there we are doing the DH81. And again, if it were to be any higher than that, it would probably be unsafe for us. And we would use the auto sampler to collect so we don't miss a good storm. Okay. And then the next set of data that we collect is continuous data. So we use deployed parameter meters at USGS gauge stations where data is collected 24/7 and reports to a data logger, which is then transmitted to the NWIS for public viewing. Here at Sligo, data is collected every 5 minutes. At Sligo Creek, we use an instrument that collects 5 parameters, which is pH, specific conductance, turbidity, temperature, and dissolved oxygen. We calibrate these meters each time we go out in the field for sampling purposes or for routine field visits. The USGS has very strict process and protocols for the data analysis and approvals. There's a lot of behind the scenes work for the data that is displayed on the web for the public to see. So here I added 2 photos. The top photo is a photo taken at Sligo from the bridge. So if you guys are on the bridge and look down to the right, that is the piece of equipment that I'm referring to. It often at Sligo loves to collect leaves. So I'm there frequently to clear the area. And then the bottom is a closer picture of the equipment that we use. Normally it has a black guard over these probes, but here's a picture without it. And you can see all the different probes here at Sligo. There's 5. Again, like I said, for pH, specific conductance, turbidity, temperature, and dissolved oxygen. Okay. And then these I just threw in because I thought they were pretty interesting. I thought you guys would enjoy seeing them. So here are 2 graphs from seasonal changes in specific conductance at Sligo. So specific conductance is an important water quality measurement because it gives a good idea of the amount of dissolved material in the water. So to the left is a graph from May 2021. So warmer, getting closer to summertime, it drops down to around 100 microsiemens. And then if you go to the right, is showing January 2022, and it's getting close to 11,000, which in the summertime, there is a lot for the rain events that we have. The rain actually dilutes the water, dropping the SC. And then January, the winter months, especially this winter, with all of our snow events, the salt that goes onto the road, when it goes down into the stream, it actually increases the SC, and we have really high SC values like you can see in this graph. But I just added those in because I thought they were pretty cool to see the drastic changes throughout the different seasons. Okay. And then, like I said previously, a lot of behind the scenes work goes into the data that is out for the public to see. So these are what we see of the same graphs that I just showed on our program called Aquarius. So for the left is the same graph that I just showed you guys for May. The right is the same one I just showed you for January. To the left, you can see that there's 2 lines. It's kind of hard to see, but there's a green one and a blue one. The blue one is showing our corrected data. That is what the public sees. And then right below it, the green line is showing our raw data. So sometimes we had to apply corrections to the data just because our equipment, it was out there for an extended period of time. 2 months is our typical time frame. But in that time, the values can start drifting from that equipment. So when we bring it back, we will do a calibration and check those values with our standards. And if they're reading a little bit off, we'll apply a correction to the data for the web or for the public to see, just because like I said, it can drift a little bit throughout the time frame that it's out, and that will give us a better accurate representation of the data for the public. So that is the blue. And then to the right, you can see that there is that green line that drops down. So there is considered what we call a spike, and that is deleted out because one of the punches, which is just a 5-minute punch, must have had something stuck on it, or could have been a leaf just brushed over the probe quickly, which gave us an inaccurate value. So we just delete that value out, and the public doesn't see it because it was not an accurate representation of the data. But I just wanted to throw that in so you guys can kind of see what we do behind the scenes and show you the different aspects of our work. Okay.
All right. Thank you, Erica. Thank you, Erica. I'm going to talk a little bit about what you see inside, what's running the telemetry for our sites. We term DCP, which is a data collection platform. And usually our sites have two different types of telemetry. Right now it's one or the other, but moving forward, a lot of times it's going to be two types within the same box for backup. A lot of our normal stream gauges have GOES satellite telemetry, which is basically where we beam data up to a satellite, and then that gets collected by the satellite, then beamed back down over in Wallops Island, and then goes on endless web. Iridium satellite is another type of satellite communication. We don't use those as much. And then the cell phone modem is used quite extensively for our water quality sites. And if you recall, Erica said that for our auto sampler, we are able to set that either from the office or even from home if we know that there's a storm coming. And that's the benefit of using a cell phone modem, because it has a two-way communication platform where we can talk to the data logger, which controls everything, say, hey, we want to sample here, and then it'll sample and send us the information. GOES is just the one way out. Then to measure the stage, we usually have a bubbler or a radar type transducer. It measures the height of the water. And then, of course, to operate these, we use batteries and solar chargers. A lot of times anymore, we are self-sufficient with solar power and batteries. We do not need a power source that way. And as you can see on the outside of the box, we do have the solar panels, antennas for telemetry, and a rain gauge sometimes as well. So that's a pretty typical setup for just about any type of USGS gauge, either for flow and water height and flow, or for water quality, or for both. At Sligo, we're also measuring the stage and the discharge of the water. So that's how much water is going through. So we call that discharge. We cannot measure discharge directly. We have to measure the level of the water, and then we have to kind of interpret what the discharge is from that. And there's a number of different ways to do this and different scenarios, but since Sligo Creek is a gravity free-flowing stream, we use a stage discharge type relationship. So we can monitor the stage continuously, like the 5 parameters of water quality that Erica was mentioning. So we can monitor the height of that water, but then we will take measurements of discharge within the stream to see what the flow is at that height of the water. So we have a couple instruments for doing that. We have a flow tracker where you can wade across and you hold the pool in the water, and it'll measure the flow going by that. And then we also have a acoustic Doppler current profiler, which is on a little boat or sled that you pull across, and it also measures the velocity in the known area in the stream bed, and gives you a discharge at that point as well. So those are the main methods that we measure discharge. And then once we have that information, we will take and let me hit the wrong button. 1 second, please hold. Then we'll create what we call a stage discharge relationship here. So we have to get out to the storms and low flows for the sites and measure the stage and the discharge, and create this relationship. And then basically the data logger will send the stage into our NWIS system, the National Water Information System, NWIS. And from there, we will apply this relationship to that, and that's how the discharge parameter is posted on our website continuously as well. We typically take discharge measurements about every 6 weeks, 6-8 weeks. We're out there measuring discharge, same way with operating water quality. And we hit storms and different flow events as needed. So, and the reason why we have to keep on taking discharge measurements all the time are if you remember in Erica's picture there, where they were sampling, I'm going to go back here. Yeah, right here. No, right here, right here. If you remember here, there's you can see the gravel bar here. And during high flow events, this gravel bar will get picked up and moved to somewhere else. And this profile of the stream, the cross section, is going to change. So when that happens, that relationship between stage and discharge changes as well. So we have to put in shifts and things of that nature to correct, to make sure that we're publishing the most accurate discharge data that we have for that. So that's why we go out and try to target storms as often as we do, and we can kind of see that from our information. This is a little diagram of kind of how the telemetry works. We have our stream gauge out there, and we send information up to the GOES satellite, and then that is beamed down to Wallops Island, and that's beamed back up to the internet and into our national water information system, and then that's the sites that you folks can access excuse me, over online. So that's how the majority, if not all, of our stream gauges work, except for the ones where we do cell phone. And that's just essentially the cell phone will send it to our office, and then our office sends it up into NWIS there directly. Wanted to mention the gold standard of quality control, and that's very important to us. Erica had showed some slides where you saw some spikes that were deleted and some corrections put in. We monitor our data, our continuous data, every day. When folks come into the office in the morning, that's one of the first things they do. They call up their sites and they look for these spikes. We're getting automated scripts now that will help us pinpoint if there has been a spike or something's not looking right. We get a notice of that, and then we go look at it. And then within 150 days of our collecting any data, we essentially, each piece of data, each data point goes through a review procedure, and it's called, we analyze it, we approve it, and we then audit ourselves. And that way we are sure that we're providing the most accurate data as possible to the public to use for whatever use they have. And even then, we're human, we make mistakes, and we still find things 10 years ago that we've screwed up or has been, not correct, or we find new information that disproves what we had collected before, and we'll go back and make sure that that has been noted in the record, and if warranted, it gets changed. But this process is an ongoing process. We are constantly looking at our records. We're trying to make sure that we are keeping up with the real-time data. You can imagine, I think I calculated that our center collected, I think it was 15 to 20 million data points this last year. And with a staff of about 40 technicians who operate this stuff, that's a lot of data to look at in that period of time. So we keep up with it the best we can and make sure that what we're showing on our real time is representative of what the stream conditions are. And Erica had also pointed out that we have SOPs for just about everything we do that have been very much reviewed, and we follow those. We have trainings and all such, just to make sure that we try to maintain that gold quality standard. The other thing that we're that's very important to us is having the data that's open to everybody. As you know, the real-time data, it updates about every hour, and the public can see that data as quickly as we see it. For samples that we collect, as soon as the lab posts the data to our website, it's posted to the public. That data is all provisional at that point in time until it goes through that review process that we have. So, you know, as a little side note with this, if you are using our data and it says provisional, just be aware it can change. We could find out where it wasn't necessarily representative of the stream at that time, or, you know, the quality control wasn't there for a sample. And, you know, if it's a really critical use of that data, you'll want to make sure that you use data that is termed approved. And after the approval process, it doesn't change nearly as much, or it doesn't change without a big, we won't change the data without making note to the record that it has been changed. And when I say changes, we're not just, you know, altering anything. We're using the other metadata that we have to make sure that it is the data is as accurate as possible. So the picture here is all of our stream gauges across the country. So you can see we have quite the network across the country. This might be a site where you're used to seeing. This is kind of the base page for the NWIS system. From here, you can access just about any data that we have. Again, that site number that I gave earlier, what is that, 01650800?
Yep.
Is something that will help you pull the data for this site. You can hit water quality, you can hit surface water on here, current conditions will all take you to that. And the main web address to get you here is waterdata.usgs.gov. And that will get you to this site here. There's another new type of website out there. It's the National Water Dashboard. I would highly recommend going to look at that. You can just Google the National Water Dashboard, it will come up. And again, that's a mapped base linkage to our sites and the data that we serve. And it will show, it's pretty nifty, it will show radar and things and the storms coming through, and then you can see what sites are in flood stage as a result, or the water level is increasing or decreasing, or water quality changing on this as a spatial type publication. So that's another very useful type of site. Again, you can also get to our data through navigating to our Maryland, Delaware, DC water science page and hit local water conditions, and that will also navigate to the data as well. So that's pretty much it for the presentation that I have right now. I'd be happy to take any type of questions. I have not been able to see anything in the chat yet. I haven't looked. So
what I was going to do, sorry, I was thinking we could unshare the screen for now, and if we need to bring it back up again for any
Sure.
clarity,
Yep.
but this way we can kind of see more of the participants and you can look at chat.
Sure.
I was going to start from Ann Vorse's question was first. Ann, if you want to, you can just unmute yourself and ask the questions. She has two questions. If you're there. Ann, are you there? Maybe not. Okay, well, I can ask her a question.
Here we
Oh,
go.
you're there? Okay, good. Go ahead. You want to ask the questions?
Yeah, FOSC has just started to have a volunteer program where we test chloride in the creek, and we're part of the Isaac Walton League's Salt Watch program with strips in their test kits. And the question I have is what can we tell the volunteers about the conductance parameter in the monitoring station at Tacoma Park that they should pay attention to or learn from? And any thoughts would be welcome.
Sure. Well, conductance, the specific conductance that we measured is very well correlated and related to chloride. You can establish a good relationship there. So one would, in a very general terms, one would expect higher chloride concentrations when the specific conductance readings go higher. And over time, that relationship should be pretty linear, where you could essentially plot the conductance versus the chloride concentrations that you're measuring, and you should get a fairly straight line relationship with that and be able to check to make sure that results are making sense. And I'll also say that we collect our discrete and storm samples also have the analyte for being analyzed at the lab. So if they were to collect and test, simultaneously with us, then there would be lab values to go along with their testing strips.
Thank you.
Mm-hmm.
And you had another question, Ann?
Yeah, I noticed that the daily readings on the monitor that we can see in real time have for dissolved oxygen and pH a lot of a wide range on a daily basis, up and down. Is this something to the uninitiated like myself that we should not be surprised at, or does it indicate something more that we should think about in terms of the characteristics of Sligo Creek?
Sure. Typically, during different times of year, you're going to have these ranges like this of DO and pH, usually from biological activity going on. And I would say the way to kind of look at this is when you're pulling the data, pull it over a long period of time. Mm. You can't see details that way, but you can see patterns.
Yeah.
If you're pulling the data and you're looking at it that way, you'll see year over year at different periods of time during the year, you're going to get these different fluctuations. Spring coming up starts a pretty wide fluctuation of DO, and that's the temperatures changing. You have drastic temperature changes, the sun's hitting the water, the leaves aren't on, things of that nature are going on. So there's a lot of activity going on. That's pretty normal. Same way, and then that in turn, it all kind of works together. pH is related to that as well. The things where, might draw a question would be if you had a pH spike in the overnight or something like that that doesn't follow any other pattern. And we've seen that before. I don't think on Sligo Creek, but we saw a very out of the ordinary pH spike. I think that was Rock Creek a number of years ago. And here there was illicit discharge there. And it spiked up to like the 11, 12 range. And it was a certain time of the day, and it happened a few times, and you could pick it out. But usually the diurnal changes like that you're seeing are, that's just some biologic activity going on in the stream. I think that's pretty normal.
Great, thank you.
Mm-hmm.
And Norman, you were asking about temperature, which they do measure, but also is organic carbon measured?
We do in TOC?
Yeah, so the temperature we collect every 5 minutes, as well as with our monthly and storm samples, we check that. And then the total organic carbon, I think we measure also for our storm and our monthly samples.
Okay.
Yeah, okay. I'm also curious, what is the typical pH range that you see?
I'm guessing it's around the 7 or 8 mark.
Yeah, we have the typical diurnal changes, but it ranges with throughout like the 7 or 8s.
Okay, and then Luke, you asked about how many seasons of measurements we have data for. So I forget, when did you mention when you started the Tacoma one?
Sligo was July 2012, so 10 years worth, just about 10 years worth of data.
Okay, cool. And then Tom, you had a question.
This may be a stupid question, but I wonder how your instruments measure stream stage when they look to be behind a weir. And the weir pretty much controls the level unless there's an extremely high flow.
Yeah, so the stage is measured via pressure, and that wherever the bubbler, and I'm not 100% now, do you know where the bubbler's at, Eric?
It's actually a little bit upstream, so it's I think it's above the dammed area, so it doesn't have that weird area or like the gravel affecting it.
Yeah, so that, you know, the goal is to make sure that site has a kind of a fixed reaction to events, and not only storm events, but also drawdown events. And so, you know, it'll measure the height of the water via pressure. And then we go out there at very low flows, and it's usually a log relationship, in fact, where the change in height varies with the flow. And we'll get to that low end of flows going there. And you're right, it might only change a little bit at the low end, but then at the high end, it'll change more. And we'll have that curve, that discharge curve that will give you the discharge that way. And we don't want the probe to dry out. And, you know, so a little bit of a gauge pool is something that we usually look for.
Thank you.
Yeah, I've got a question, sort of a follow on to that. You know, we know very well that this is a flashy creek, and it's flashy enough so that on the big events, the 3-inch, 4-inch rains, we get flooding across the floodplain.
Mhm.
So I've watched your, I see the gauge, I check the gauge every time there's a big rain, and it'll go up to, 2,000 cubic feet per second or something. But I'm assuming that you don't have a way to measure the volume when it's all the way across, because that's not putting pressure on the creek. It's like, the pressure is expanded all the way 100 feet wide, 150 feet wide. So how do you, I've always figured that 2,000 in that circumstance is way low.
What we do in those situations, if we measure a flow where it's out of the banks, or if it's higher than we've ever measured before, and then we've actually got a measurement for, we'll go back and we do what we call an indirect reading, where we'll go and look for high water marks, and we'll flag those, and then we go in and survey those, the elevation of that in a particular reach, and then we'll do computations that will calculate based on a slope of the watershed in the area that was wetted, the discharge at that point in time. And then we'll match that with the height of the reading that we made, or that our sensor had made, and we extend the rating out to that distance. So usually if we will not publish something that is out of our extended range. So at one point in time, we don't do that all the time, but we will make sure that if we measured what we call a peak of record, we will have that stage discharge relationship calculated that far. And I would have pretty good confidence in those numbers.
And so I have to, so I can't see, I'll not be able to see it on the chart because the chart, I mean, the chart is whatever, logarithmic or something. It's,
Yeah,
you can't, you know, the difference between 2000 and 3000 is this big and 0 and
right.
5 is this big. So
Yes.
you have to go to a different measurement area to see like what the actual, what you're talking about, which is going after the fact, seeing that there was a foot of water at where Kennebec came down. And so
Yeah.
yeah. So how? So you see, I would see that like a month after the fact, or
Yeah, it would. Yeah, it would be. It would be something that we would make sure that we wouldn't approve and publish that flow, that peak discharge, until we had done something like that.
okay. Thanks. Sam, I think you're next. Stokes.
Yeah, I was interested in what changes you have seen in the data over the years that you've been collecting, and what those changes might indicate as far as the watershed is concerned.
Yeah, so we've collected the data in the past 10 years, and I'm hesitant to say about changes we've observed because I haven't done a formal interpretation of the data to say that. So I have to be kind of careful on what we say we've seen, and when we do that type of interpretation, we use a lot of statistical models to say whether there are trends or not, and that kind of keeps us out of a little bit of trouble from making some false statements on there. So I appreciate your question, and I actually have some of the same questions, but right at this moment, we don't have a project in there in the house to do that interpretation on this site. So I'm sorry I can't give you more details than that, but that's I'm going to kind of pass on that question.
Is that type of analysis possible on sites where you've had a longer history?
It is possible, and a lot of it comes down to funding, whether or not we are funded to do that type of analysis. A lot of sites in the DC area are part of the Chesapeake Bay non-tidal network. And after 10 years, those sites start having trends being analyzed, particularly for nitrogen, phosphorus, and suspended sediment. This site, for one reason or another, is not in the non-tidal network. It's the sampling procedures vary a little bit from that, and it's not in there, so it doesn't get that benefit of, I wouldn't want to say free, but other funding paying for those analysis of trends.
Thank you.
Mm-hmm.
Pat, this is sort of correlated to the same question, but you want to ask your question?
Yeah, sure. No, actually, I think Sam pretty much got my question. I was curious about point of rocks and other gauges you've had going for quite some time. If you're seeing, trends that you can talk about. And then also I'm curious how the DC, Delaware, Maryland area is doing compared to other regions around the country, if that analysis has been done.
Yeah, I don't know if that analysis has been done for comparison wise about urban areas. I know, with urban areas versus, there's been a lot of urban versus forested type comparisons and all that. And we all know that the flashiness and things of that nature with the urban, and the water quality, the higher specific conductance are typical in the urban areas. But as far as comparing this area with like Baltimore or even New York or out west, I don't know if that has been done formally. There, USGS has what they used to have, National Water Quality Assessment Network, NAQUA, that did a lot of data collection and comparisons, and there are articles out there about that. I can guarantee you that if that comparison's been done, in which we can maybe do some follow-up on that and send out the publications that would lead to that. In the same way with any type of trends for stream flow as well, in across the country. So we'll follow up with you on that, see if there has been anything published on that.
Appreciate that. Thanks.
Norman, you had an additional question.
Yeah, I'm wondering where the other nearby monitoring stations are. I mean, is there anything upstream in Sligo Creek or on the northern branch of the Anacostia?
So in the area, we monitor a number of different streams. Let me just spout some out, and we can maybe if the computer gods are with me, pull up a map. Right, 1 second here. I think we're going to call it, let's see here. Close my presentation. Water dashboard. All right, I'm going to share, if I can get back to Zoom here. I'm going to share my screen, and bear with me because we're doing this live, and usually when I do internet stuff live, it doesn't go well, but we'll see
what happens.
Do you all see my screen here? National Water Dashboard?
Yes. Yeah, it's on.
So we're going to zoom in. Let's see here. All right, here we go. So here's Sligo. And then we have Rock Creek. We have 2 sites on Rock Creek, Sherrill Drive and Joyce Road. Joyce Road, we collect water quality and sample and discrete samples like we do at Sligo. Up here we have Paint Branch. Paint Branch is also a water quality and stage discharge and samples collected site. We have Northwest Branch Anacostia at Colesville, which is just a discharge site. And what's this one up here? Is that Paint Branch again? Paint Branch Trib. It's in Colesville. Then at Northeast Branch, we have a 5-parameter water quality sonde. And Northwest, we have, I think, turbidity specific conductance and discharge as well. So Northeast, Northwest. Hickey Run within DC, Beaver Dam Creek, right on the border with DC and Maryland, and Watts Branch. So that's kind of
What do you have on the west? You've got, because I know Sarah Morse is on here, the call.
Yes. So out west, here's the Potomac Little Falls. So that's a 5-parameter sonde on Potomac. This is Dead Run. Now we don't operate this one. This is in Virginia, but that's being collected as well. I will note, let's see here, there's Difficult Run, another monitoring site. And let's see here. And then that's getting way up the Potomac.
Yeah, thanks.
We're working with COG, and since a lot of DC drinking water is pulled from the Potomac, we're working on putting more continuous monitoring sites on the Potomac and its tribs to help kind of as an early warning type system if there has been a spill or something like that, to give them a heads up as quick as possible to shut off their intakes and such. Then down in DC, we have the Anacostia right at Buzzard Point. And then we also just put in one of our, and this might be of interest. Let's see here. Where's our newest? That's Beaver Dam. We're up a little bit. Is that not on here yet? Oh, we might not be publishing. Let me see if we can go to water quality. 1 second here. It's a very new site. Let's just do temperature on. Okay. Right here, Bladensburg Waterfront Park.
Oh, good.
That site is brand new. It's going to be what we term a super gauge, where we'll have the 5-parm water quality sonde there. And then we're also going to have a real-time bacteria sensor working there as well that will do essentially a lab type test in the stream and give us the results within some hours of that. And then some other instruments there as well to help kind of predict bacteria concentrations. So those are really the closest ones that are around.
Well, the Bladensburg one should be a great educational opportunity just because of its
Yep.
location, and so there's so many people go there for a whole variety of different things.
Yep, for sure.
Huh, cool. Are there other? You don't have to have put yourself in chat. Are there other folks who had any questions that haven't been covered? Kathy, Ed, Elaine, others?
I have a follow-on question to Pat's question. What would have to happen in order to have trend analysis done for Sligo Creek? Would that have to be requested by the county or some other agency and funded?
Yes, I mean, essentially, we would need it to be funded. Again, like I said, we essentially all the work we do has to be funded by a cooperator of such, and that's what we would need. You know, we would be in contact with whomever might want that, and we'd work out the details on what exactly they're looking for, and then we would figure out the effort for that and work on a funding agreement with that.
Thank you.
You know, one thing, we work a lot on stormwater related projects, and especially as we can see from the results so clearly, how we don't have enough stormwater projects in our watershed because we're still so flashy. But it's really the Department of Environmental Protection in Montgomery County pays attention to your measurements and to understand the seriousness of the problem here, and they also pay attention to the rainfall amounts. And as I mentioned before the program started, I'm one of the many hundreds of community collaborative rain, hail, and snow volunteers, so I know how much precipitation we've gotten over in a 24-hour period. So we've got your data, we've got my data, and a bunch of other people's data that tell how much rain fell. You've got how flashy this creek is, and Montgomery County knows where stormwater projects are, but arguably then, thinking about how to increase that and how to look over time again. Look over time, how, what the changes are, because we have the rainfall data, we have your cumulative data over 10 years, and they've mapped where the stormwater projects are and how much stormwater gets collected in each one of those, and they can add them all up and put a PhD student on this project, and you've got some interesting stuff. I'm just saying it's really that we have a lot of data points, and we're doing a lot of work, but it's, and the problem is, I mean, I know from talking to people in other creeks that some of their creeks are not as flashy as Sligo is. There's good reasons for that. We've got a ton of impervious surface around here, and it's a skinny little creek and a skinny little park, so there's not a lot of forest, unlike Northwest Branch, for example. Yeah. But it's, so anyways, there's a lot to play with here and think about. That the data you're collecting is going to be a critical piece to understand that on a wider area. It'd be nice if you had, 100 USGS sites in Montgomery County instead of whatever 5.
Yeah. No, it is, and again, that long-term data where you can, sometimes we get questions about, well, what was it like here before when we didn't monitor? And those questions are really hard to answer. And that's the benefit of establishing these monitoring sites early into any type of remediation process is that you have that baseline data then to see whether things are working and helping out. And if they're not, then, you gotta either do more or do something different.
Right. Well, we know that in 1930, up to 1930, Sligo Creek was a drinking water source for Tacoma and Silver Spring and Kensington and some other places. So
Yeah.
the water quality was much better than it is. And it was
Yeah.
also a much high, it wasn't flashy. It was a reliable source. People were boating just,
Yeah.
a half a mile downstream from where your collection is.
Yep.
So, so we do have data. It's just not your data. Jean, you had a
Yeah, I just wanted to kind of follow on to, I think the point that you're trying to make is how do we know if things are getting better? Here in Tacoma Park for a long time, we had to pay a separate stormwater fee. And now it's just rolled into our property taxes. And they've done different projects one way or the other, but we never know whether that investment is making a difference or not if we don't have some sort of analysis of the data from the creek. And I know that USGS isn't the only one that's monitoring it, but it's just when you're talking about allocation of public resources for cleaner water, cleaner streams, it's really hard to tell without that trend analysis. So I wanted to ask Chuck, when he said somebody has to fund it, I'm assuming pay the USGS to do that trend analysis, or can the USGS allow their data to be given to others to analyze it, just the raw data, or is that allowed?
That is, it's out there now, and anybody can use our data to do anything they want with, and we have no problems with that one bit.
Okay, so are you talking about to go back and look at all this data you've collected for 10 years, is it right, 10 years? And to analyze it? Is there any kind of a cost figure on that? Does any,
well, there's no cost for someone to use our data to make that analysis. If we were to do the analysis, there would be a cost with that. You know what I'm saying? So if someone, some PhD student wanted that as their project, they could get all access to all of our data very easily and free to do that analysis. If people from our office were to do that analysis, then we would have to work up an agreement to fund their time to do the actual interpretation and analysis of the data.
Well, say if I went to the city council of Tacoma Park and say, we really need somebody to look to see if this stormwater fee, the activities that it's funding are doing any good. And they said, fine, who should do it and how much would it cost? Is there any way to know that?
Probably there's a number of folks that could do it. There's probably academics, and then there, our center and USGS could do that as well. And then depending on the type of analysis and the publication of it would depend on the cost of it. And I would hesitate to venture a cost right now. It wouldn't be a insignificant amount of money. It would be, a chunk of change to do that, because, when there is an analysis done like that, there would be, it'd have to go through public, a report would be written that would go through peer review and publication, and then that would be released to everybody then. So it's probably in the tens of thousands of dollars.
There's a bunch of different things that I think you're getting at, Jean, and a lot of this isn't related to the data you all are collecting. I mean, the county and the state do water quality testing, and in fact, they've done it over time. And in fact, Sligo Creek is getting cleaner. We used to be entirely rated poor. We are no longer entirely poor. Some of us, some parts of the creek are rated fair, and that is that's a significant improvement. We also, the county and the state and others do testing for how many kinds of fish are living, how many
Right,
and
right.
varieties, how many fish are living in the creek, what kind, how many species, how many, all of that stuff. And that's very much on a healthy trend, and obviously not USGS stuff. The other thing is just specific to what you're talking about. The that recording place is covers only a very small amount of Tacoma Park, and probably the majority of the watershed of Tacoma Park hits the creek downstream from where that measurement is. And
Yeah, I wasn't able to tell from the pictures where
it's just above Maple Avenue.
just above Maple Avenue.
Yeah,
Okay.
so just west of that is Silver Spring and not Tacoma Park. Just east of that is a small, on the east side of that is Tacoma Park. So, to get at the question you're asking, you have to go sort of to other data to try to find that out. And but there is some other data, and the generalized data, is showing some good things. One thing I want to also mention is Pat Ratkowski, who's just now, we can see his face, is helping to do a lot of water quality testing up and down Sligo Creek, and so he's measuring a whole bunch of different kinds of data that USGS is not, some of which they are measuring and some that they're not, and it's obviously more segmented because he's not out there 24/7 in the entire creek. Pat, I don't know
Well,
if you
you
wanted to.
mentioned something about the fish.
Yeah.
I remember when they announced the joint effort of the three jurisdictions, Prince George's County, Montgomery County, and DC, to clean up the Anacostia, and there was all the politicians were there. Friends of Sligo Creek had a booth at that, and I talked to somebody, and I evaluate maternal child health programs in developing countries for a living. So evaluating the effectiveness of programs is what I do. So I asked this person, I said, how do you know, what indicators do you use to say that things are getting worse or getting better? And he pulled one out and he said, well, when I started in this, there were only 3 species of fish living in Sligo Creek, and now there are 10. Now that's more than 10 years, that's like 15 years ago. So
Yeah,
I mean, to
there's
me, that's
more now.
one
There's
indicator, which
I think we're at 20
Geological Survey is not doing. I understand that. When it gets to the kind of things that he's talking about, that's where a common citizen like me, with a pretty strong but not a professional background in biology or geology, I need it boiled down and simplified for me. Is it getting better? Is it getting worse? What else needs to be done? So I'll leave it at that.
Okay. Pat, did you want to say something?
I can just say, yeah, I think Kit is right, Gene, just from what we've seen from Parks. Rachel Gauza, I don't know if you know her, but there's a great graph. We should probably just go ahead and put it up on the site. If we don't have it already, I'll talk with Michael Wilpers in Natural History. But the trend is definitely positive over the past 20 years. It seems like the 90s were kind of the nadir, and it's not linear, but it's in pretty good shape. So they're starting to find some species, some vertebrates, fish that are not tolerant, which is what we want. Fish that need cleaner water are now starting to reappear, at least at this site that Parks measures each year. So that's a very positive sign. We would not have seen that species apparently 10 years ago. So
What was the name of that species again?
I think it's the northern hognose. I can check it here.
Oh, yeah.
Hogsucker?
Hogsucker. I think that's right. Yeah.
I
Northern
read the
hogsucker.
survey from a few years ago. I don't know if there's been any done since I looked at
Yeah.
that. And yes, they were pointing out that there were certain species that were showing up that are only in relatively clean water. So that's a kind of indicator. What the indicators of success would be.
Yeah, I think that's been found the last 5 years running, I think, which is extremely positive. The thing next, I think, to do, from what I can tell with Audubon, is your macroinvertebrates are kind of the base of the food chain. So if we can get a better, more consistent look at what's going on with the macros, that would be helpful as well to sort of track what's happening.
Excellent. Thank you.
Welcome.
We're getting close to the end. I wonder if Erica or Chuck, you wanted to make any additional comments before we close it out?
No, just I want to thank you all again for having us, and we certainly appreciate it. If you ever have any questions about our data, where to access it, what we're doing, please feel free to contact us. We'll definitely help you out. I think even on the site, there's a Ask USGS button, and we take those requests very seriously. So you just hit that, and probably within a few days, you'll get an answer. Because it takes a little bit of time to route it to the right person. So yeah, you can contact myself or Erica or however. But yeah, thank you again. And
Thank you. And we'll be getting you, we'll put these Friends of Sligo Creek mugs on the USGS box, and you can pick them up, or else we'll deliver them more personally.
all right, that sounds good.
Thank you so
thanks
much.
very much.
Here's a
Really good.
Thank you, guys. And
Thank
if
you
you ever
all.
see me, come stop at the gauge box and I can give you more in-depth, in-person explanation thing we have on site.
Terrific.
Fantastic.
Thanks so
Thank
much.
you, Erica.
Thank you both very much. It was
Thank
Thank
perfect.
you, Tom.
Have a good night.
See you
Good
guys.
night.